Welcome to 1.6. In this section, we're going to focus on division and how it's related to multiplication and some of the interesting properties that go along with it. So, some of the keywords here that are important to talk about. In division, we have a dividend and a divisor, right? The dividend is the thing that you're dividing by the divisor. And then the result is the quotient. And most classically, you're probably used to something like long division. That's our kind of standard procedure for doing division by hand, and we'll go over that. And we'll talk about what a remainder is and how it's related to the quotient. So the first thing we're going to do is we're going to divide. And we're going to do this as an example altogether. So the very first thing I want to do is do a quick little investigation of the problem and what I'm going to be doing, and maybe come up with even an estimate, because division is very algorithmic or procedural, and so it means sometimes we can get lost in the steps and forget to common sense check our work. And so just really quickly, let's think about this. 595, it's close to 600, divided by 7. If it were 600 divided by 6, it would go in 100 times. And so because 7's a little bigger than 6, it won't quite fit in as many times. So we're looking for an answer that's less than 100, but on the way to 100. It's going to be a big number, maybe around 80 or 90, around there. So that's kind of our quick little investigation. So we think, I'm going to put over here, I'm going to put a little estimate here of about 85. I'll take the average of 80 and 90. And so now we're going to do it. And we'll check our answer, and we'll go from there. So the way division is written is often with this division symbol, but that doesn't do me too much good. What I really want to do is write it as long division so that I can do some work and stay organized. So what I'm going to do is I'm going to divide the 7, and instead of starting with the ones unit, I'm actually going to start with the lead digit here, which is in the hundreds place. So I'm going to say, does 7 go into 5? And it doesn't go in. I could put a 0 there, but I don't really need a 0. Right? I could put 1 there, but I don't need it. So instead, I'll just go to the next place. And instead of looking at 7 into 5, I'm going to look at 7 into 59. This is why it's important to know your times tables. So 7 definitely goes into 59 some amount of times. It doesn't go in evenly. So there's going to be some kind of leftovers. Let's see. 7 times 7 is 49. 1 more 7 is 56. So that's 8 sevens. So 8 times 7 is 56. And then what we do, once we multiply back, is we subtract so that we can find out what the leftovers are. 9 take away 6 is 3. 5 take away 5 is 0. So that's all that's left there. And then what I'm going to do is bring down the other digit that I hadn't used, in this case of 5. So 7, does 7 go into 35? Yep, 7 definitely goes into 35. How many times? Let's see, 7 goes into 35 5 times. 5 times 7 is 35. And then I subtract 35 minus 35 is 0. So I have no remainder. So this is great. No remainder. And, sure enough, it matches my estimate here. But that was just kind of luck. Now, how can I check division? Anytime I do a division problem, how can I check to see if I'm right? I can do multiplication. So I can check to see, okay, well, if 595 divided by 7 equals 85, then that means that 7 times 85 equals 595. That's what I'm suggesting. So I can check this by multiply my divisor and my quotient to see if I get my dividend. 7 times 5 is 35. Carry the 3 over. 7 eighths are 56, plus 3 is 59. Oh, sure enough, it checks out. Okay, great. So it went in evenly. I had no remainder. That's what it means to go in evenly. And then I multiplied back to check. That's great. And now in this example, this is the same example. They're going to walk you through, you know, how to do it maybe a little neater, and then they're going to check it. So I encourage you to go through this example. If you have any trouble with division, please make an appointment with me and we can go over it. Let's do another problem. So instead of dividing by a single digit, we're going to divide by a double digit number. So we're going to divide 1,872 by 18. Well, 1,800, 1,800 divided by 18 would go in 100 times. So this goes in at least 100 times. It looks like maybe 105 or so times. Definitely less than, say, 110 or 120. Definitely more than 100. So when I estimate here, I'm going to estimate 105. I actually think it's a little less than 105, but it's definitely more than 100, right? So I'll say in between 100 to 105 is probably a good range for this answer to be in. Okay, so now that I've kind of got a common sense foundation, now I can go and I can concern myself with the procedure. So 18, does it go into 1? No, it doesn't go into 1. Does it go into 18? Oh, how convenient. It goes in 1 time. 1 times 18 is 18. And then I'm going to take away that. I don't have anything left over. Does that mean I'm done? Not exactly. It means that I've got to bring down everything in my dividend until I've divided into everything. And I have no remainder at the end in the ones column. That's the key. So 18, does that go into 7? No. So should I bring down the 2? Not until I put a 0 in here as a placeholder to show that 18 didn't go into the 7. And then I can bring down my 2. Does 18 go into 72? Yes. Now here's the trouble. I don't know exactly how many times. So I have a couple of different options. I can guess, and I can just start doing some math. I can do it off to the side. One thing I like to do is just do a quick little, maybe 18 plus 18. So that's 8 and 8 is 16. That's 36. Ooh, 36 times 2 is 72. Oh, so that means that 18 times 4 is probably 72. So let's see. 4 eighths is 32. That's the 2 I needed. 4 ones is 4 and 3 is 72. Yep, great. So 18 goes into 72 4 times, and 4 times 18 is 72. I have to show this work here. 72 minus 72 is 0. So with no remainder here and nothing left to bring down in any other column and any other place value, I'm done. And my answer, my quotient, is 104, 104. So 1,872 divided by 18 is 104. And then I can check it. So I can say 104 times 18. And this is why multiplication is so valuable, because it helps us check all our division. 8 fours is 32. 8 times 0 is 0. Plus 3 is 3. 8 times 1 is 8. Now when I go to the tens column, I have to add a 0 to show that I'm starting a place value in. 1 times 4 is 4. 1 times 0 is 0. And 1 times 1 is 1. I have these two subproducts, right? I have 8 times 104. And then I have 10 times 104. And I can add them together. 2, 7, 8, 1. So then it checks out. 18 times 104 is 1872. So that means my answer was right. And have a look at my estimate. Was my estimate pretty good here? I knew it was more than 100. I said about 105, and we ended up with 104. So not bad at all. Now this is the book showing you maybe a slightly neater version of exactly what we just did. Now this is the maybe the most interesting part of this section, and the most important part is to talk about division by zero. So the first thing I guess I'd like to think about is, what even is division? Well, if multiplication is repeated addition, then division, let's see here. Division is repeated subtraction. And this is important because it's going to help us to understand, so we don't have to always remember all these rules. So let's do something like this. Let's do 8 divided by 2. Now you already know what it is, right? 8 divided by 2 is 4. Why? Well, a couple of reasons. You can take you can take 8 things and you can say, well, what if I split them into 2? What would I have? Oh, I'd have 4 in each group, right, if I split them in 2. That's one way to think about it. Another way to think about it is to think about it as repeated subtraction. So if I take 8 and I take away 2, right, this is 1, 2, I've taken away, I'd have 6 left. If I take away another 2, that's the second 2, I'd have 4 left. If I take away another 2, the third 2, I'd have 2 left. And if I take away 2 more, I'd have 0. And that's the fourth 2. And that's why 8 divided by 2 is 4. Or one of the reasons, one of the ways to think about it. Now let's do that same thing with 0. How about 8 divided by 0? So I'm taking 8 and I'm going to subtract 0. That's the first 0. What do I have left? 8 minus 0 is 8. Okay, so I can do it again. Take away 0. That's the second 0. 8 minus 0 is 8. So I can do it again. I can take away a third 0. 8 minus 0 is 8. So you can see what's happening is I can take away an infinite number of zeros from 8, and it would never decrease. It would never diminish. And so what that means is that whenever I divide by 0, the result is undefined, because really the answer could go to infinity. There's no way to know it. It's not defined. So whenever we divide by 0, it's undefined. One way to think about it is if the number comes first, that's okay. Or excuse me, if the 0 comes first, that's okay. If the 0 comes in the back, that's a no-go. That's one way to think about it. Right? Because I can do 0 divided by 8. 0 divided by 8 is 0. Because if I try to take an 8 away from 0, I can't even take a single 8 away from 0. And I'm already at 0. So I can take no 8s away from 0. What's the mathematical equivalent of taking nothing away? 0. But in this case, when I divide by 0, 0's on the back end. 0's outside the house, right? In long division. This is undefined. Undefined. And I have to write it out in words. It's one of the times that in math I actually write it out in words. It's undefined because I could take away an infinite number of zeros and wouldn't make any progress. So hopefully that makes sense, and it's a way to understand it that you don't have to maybe remember as much. Okay, let's go over these problems here. So go ahead and pause it and take a look at these yourself, and then we'll look at them together. Okay, so which sentence below describes the problem shown in example 1? So hopefully you remember example 1. Is it A, the quotient of 7 and 595 is 85? Is it B, 7 divided by 595 is 85? Or is it C, the quotient of 595 and 7 is 85? That's right, it's C. The quotient of 595 and 7 is 85, because that says the quotient, which says the division of two things. The first thing is 595, the second thing is 7, is equals, right? Is the mathematical equivalent of equals 85. So 595 divided by 7 is 85. The quotient of 595 and 7 is 85. All right, so that's A. Part B, to find a solution to a division problem, how would you think in terms of multiplication? Well, you want your quotient and your divisor to multiply to your dividend. And so when you're dividing in, what you're really thinking about is, what's the biggest multiple of the number that I can get out of it? So that's how I would describe that. So thinking about, to find a solution to a division problem, how would you think in terms of multiplication? So say, the easiest answer is quotient times divisor, right? That should equal your dividend. But we talked a little bit more about some of the subtleties. All right, C. Example 5 shows that 1,690 divided by 67 gives a quotient of 25 with a remainder of 15. If we were to divide by 1,692, if we were to divide 1,692 by 67, what would the remainder be? Well, let's see. We could either do it ourselves or we could think about it. So if I divide 1,690 by 67, I have a quotient of 25 and a remainder of 15, R15, so 15 left over. If I were to divide 1692 by 67, it should still go in 25 whole times. And then the remainder should be, would it be less or more? Because 2 more wouldn't be enough to get a whole nother 67 in. But it would increase the remainder by 2. So it would go in 25 times with a remainder of 17 this time. And hopefully that makes sense to you. Let's go ahead and do it really quickly. So it does. Since we didn't do this example earlier, actually. So 67, will it go into 1? No. Will it go into 16? Not even. Will it go into 169? Yes. 67 is close to 70. 2 70s would be 140. I don't think it'll go in 3 times. I'm going to put my money on 2 times. Because 2 7s is 14. And 2 6s is 12. And 1 more is 13. So that's 2 67s. Take that away. I'm left with 35. Bring down my 2. 67 into 3, 52. Let's see, 60 would go into 300 5 times. So it'll definitely go in 5 times. Let's see, 5 7s is 35. Carry the 3. 5 6s is 30 with 3 is 33. Take it away to see what's left. We have to borrow here. That's a 4. That'll be 12. 12 take away 5 is 7. 4 minus 3 is 1. And then the 3's are left. So there it is. There's your 25. That's how we got the quotient of 25. And the trouble is, the remainder's not 0, and I'm done bringing things down. So that means that's my remainder, 17. All right, let's look at D. And hopefully you can explain this on your own now that we've gone through it. But explain why division by 0 is undefined in mathematics. Well, you could say it's the rule, but that's not really why. So explaining why is like saying because division is repeated subtraction, you can take away 0 an infinite number of times. And never obtain a quotient. So that's what I would say. Just kind of in, quick, simple language. You can take away 0 an infinite number of times and never obtain a quotient. And so for that reason, dividing by 0 is undefined. And we have to say undefined whenever we encounter division by 0. So hopefully that cleared up division for you. And if you have any questions, let me know. And we'll see you for our last section in Chapter 1, 1.7 next time.